All right, what's up, everybody? We're moving on. This is our last lesson in chapter 4, 4.4, slope of parallel and perpendicular lines. So last lesson in 4.3, we did a review about slope and slope-intercept form of equations of lines on graphs. And today we're tying it into how it fits with chapter 4, parallel and perpendicular lines. Okay, just some review. Oh, sorry, before we get going, like always, go into Canvas here on your home page. Chapter 4 notes 4.4 are there. Chapter 4 slides 4.4, these are there in Canvas. Okay, so just some review. Parallel lines, lines that are coplanar and never intersect. Here's an example of parallel lines. And perpendicular lines are lines that intersecting lines that meet at 90 degrees or meet at right angles. And there's your example there. So parallel, never cross each other. Perpendicular, always cross each other and always cross at 90 degrees. Okay, so just some quick review from what we did on last lesson. Just find the slope of the line. Okay, let's take a look. We're starting here, going to here. Notice we are going down 1, 2, 3, 4. That's a -4. And then we're going over 1, 2, 3, 4, 5. Remember, slope is always change in y over change in x. All right, so this one we went down 4, we went +5. So this slope here would be -4 over 5. Here we're going up, so that's going to be positive 1, 2, 3, 4 over 1, 2, 3. So that's +4 over 3. Okay, so just a quick review, finding the slope. Okay, finding the slope of parallel lines. Notice there's no points in here for us to make it a little bit easier, so we got to find in our own points. So let's say that we cross right here and we cross right here. Let's count. What is the slope? 1, 2, 3. We went down 3 and we went over 1, 2. So the slope of this line is -3 over 2. And if I use a different color, right? Remember, these lines are parallel, so they're never going to cross each other. There's a point, and there's also a point. We're going to go down 1, 2, 3, and over 2. Notice this also has a slope of -3/2. Okay, these two parallel lines have the same slope. Interesting development. All right, finding the slope of parallel lines. Again, let's take a look. This blue line, we see that we intersect here and we intersect here. We go up 1, up 2, over 1, right? So the slope of the line A is 2 over 1, or it can just be simplified to 2. And if we find the slope of the red line, notice here's a coordinate, here's a coordinate. We go down 1 over 2. So the slope of the red line is -1 over 2. All right, well, take a look. Notice, right, if we put those side by side, red and blue, -1/2 and +2 over 1. We've used the same numbers. They've just flip-flopped sides, right? One is on top, one is on bottom. And also there's an opposite sign, right? So one of them is negative, one of them is positive. Also, interesting development. So we can conclude that slopes of parallel lines are always going to be the same. All right, that is the trick. That is the key there. Slopes of parallel lines will always be the exact same. Slopes of perpendicular lines are what we call opposite reciprocal. All right, fun phrase to say, opposite reciprocal. And the opposite reciprocal means that we flip the numbers and flip the signs. Okay, so similar what we just did in that example, right? We had -1 over 2 and +2 over 1, right? We flip the numbers and we flip the sign. And you can do that with any number you want. Okay, you can have +3 over 5. The opposite reciprocal would be -5 over 3. If we had two lines with these slopes, they would be perpendicular to each other. And again, you can do literally any number you want. You can have -17 over 2, and the opposite reciprocal of that would be +2 over 17. Okay, you can do it with any number. Opposite reciprocal. Okay, so now decide, are these lines parallel, right? Always look at the slopes. All that other stuff in there is just nonsense and distractors. Okay, so always look at the slope. Here we have a slope of 2, slope of 2. Remember, we said slopes of parallel lines are the same. So our correct answer here is yes. Yes, these are parallel. Okay, let's take a look. Slope is 1/2. Slope is -2. That is a no. Those are not the same. Parallel has to be same slope. All right, take a look here. Negative 4 over 5, negative 4 over 5. Those are the same. Yes, those are parallel. Okay, now are these lines perpendicular? Remember, I'm going to regret having to write this, but those are opposite reciprocals. Opposite reciprocal. Flip the numbers, flip the signs. So here, notice it's kind of hard to write fractions linearly. So let's say this is 2, 5, and negative 5 halves. Are those opposites? Yes, they are. The correct answer there is yes. Here, negative 3. Remember, if it's a whole number, you can technically put 1 underneath it at all times. Negative 3 over 1, and here we have negative 1 over 3. Right? These are reciprocals because we flip the numbers. However, they are both negative, so they are not opposites. So they are reciprocals, but they're not opposites. We need both opposite and reciprocal. So this one's close, but it's still a no. Okay, and these last one, negative 1 over 2. Remember, 2 can be always changed to 2 over 1, so we have positive 2 over 1. All right, that one is a yes. Okay, so now determine if the lines are parallel, perpendicular, or neither. So you do the same thing. Find out what the slopes are. Are they the same? Right? This means that they are the same if they're parallel. Perpendicular means they're going to be opposite reciprocal. Reciprocal, man. And neither is just like literally anything else. Anything else. They could just be two other random lines. Okay, so again, look at the slopes. 1/2 or 2. Remember, 2 can be 2 over 1. These are reciprocals because you flip the numbers. However, they're not opposite as well. So this one is close, but it's tricky. That one's going to be a neither. Here, let's take a look. 3, 3, same exact slope. Those are going to be parallel. 4 and negative 1 over 4. Remember, 4 can be changed to 4 over 1. We flip the numbers and we flip the signs. So these are going to be perpendicular, perpendicular. And here we have 8 and 6, literally not even close. These are just neither. These are just two random lines living their best life, but have no relationship with each other in terms of parallel or perpendicular. Okay, so now creating equations of parallel and perpendicular lines. Remember the rules of the slopes. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. If given a point, you can always find the equation. This is in lesson 4.3. We found out how to find an equation based off of a given point, using the slope and plugging in for m, using the coordinates and plugging in for x and y, then solve for b to find the y-intercept and rewrite as y equals mx plus b. Okay, so here's an example. Write an equation that passes through this coordinate, 1, 1, and is perpendicular to the line y equals negative x plus 6. So first, let's think. We're perpendicular. That means our slope is going to be opposite reciprocal. I'm just going to abbreviate from now on. Opposite reciprocal of the slope of this line. The slope of this line is negative 1. Negative 1 over 1. So the opposite reciprocal of negative 1 is going to just be positive 1. Right? So that's going to equal our new slope. And remember, that is our m. So if we think y equals mx plus b, we know that our slope of our new line that's going to be perpendicular, the slope is going to be positive 1. Take the coordinates. X is also 1. Plus b, we still don't know. That's what we're looking for. And our y value, right, that's our x value, that's our y value. Our y value is also 1. There's a lot of 1s in there. So now we multiply. 1 is equal to, 1 times 1 is still just 1 plus b. To find out what b is, we subtract 1 from both sides. Those end up just canceling out, and 0 is equal to b. So now this is our m, this is our b. We plug it in, y equals x plus 0. Or we could just write y equals x. And that line is going to be perpendicular to that line. Okay, perpendicular to that line that will cross through that point 1, 1. Okay, Now, write an equation of a line that goes through the point -2, 3, and is parallel to this line. So remember, now if we use a different color, parallel means same slope. The slope of this example line is -2 equals -2. All right, same slope has to be -2 because that line is -2. So again, y equals mx plus b. We have our x value, we have our y value. We just found m's slope was -2. All right, so just plug in our values. The y number was 3 is equal to -2 times x, which is -2 as well, plus b. We're finding b. Multiply this out. 3 is equal to +4 plus b. If we subtract 4 from both sides, those cancel and we get b is equal to 3 minus 4 is -1. So now our y-intercept is -1. If it has to pass through this point, we have our slope y equals -2x minus 1. This line will pass through this point and will be parallel to this line here. Okay, this is our correct answer. Now write two equations that pass through the point 4, 1 and is parallel and perpendicular to the line y equals 2x plus 1. So now we're writing two lines. We need one that's parallel. We need the one that's perpendicular. All right, so last time we did parallel in red. Parallel is going to be the same slope as here, which is, again, this is 2. So for our parallel lines, this is still our x coordinate. This is still our y coordinate. We have y is equal to mx plus b. We know that parallel has to have, that's an arrow, same slope to 2. So we plug in 2 here. We plug in y, which is 1. 1 is equal to 2 times x, which is 4, plus b. All right, multiply it out. 1 equals 8 plus b. Subtract 8, and we get b is equal to 1 minus 8 ends up being -7. So for our parallel line, our equation is going to be y equals 2x minus 7. Sorry, that's okay. I'm going to erase that. That was bad. 7. All right, that is the equation of the parallel line. Now for perpendicular, if we use a different color, remember perpendicular, those are opposite reciprocal, right? And if our slope here is +2 or +2 over 1, the opposite reciprocal is going to be -1/2. So now we've plugged those in. Y equals mx plus b. Remember, they're still going through the same point. So for our perpendicular, these are still our x and y values. So we plug them in. Y value is 1. M we said was -1/2. And x we said was 4 plus b. All right, so 1 equals -1/2 times 4 plus b. 1 equals -1 times 4 is -4. -4 divided by 2 is -2 plus b. All right, now if we're solving for b, we got to add 2 to both sides, and we get b is equal to, those cancel out, b is equal to 3. So now our entire equation is y is equal to -1/2 x plus 3. The equation of this line will be perpendicular to this line and pass through this point. This equation will be parallel to this line and still pass through that point. Okay, and that's all I have. Notice Desmos is a really good option for you to practice with that.